Well, so far in this course, we've introduced the del operator. We've seen how it operates on a scalar field to give us what is called the gradient of that scalar field. The gradient itself is a vector, which means it has both a magnitude and a direction. And the direction of the gradient vector points in the direction where the change in the value of the scalar field is the highest. Conversely, if you move in a direction exactly opposite to the direction of the gradient vector, we move in a direction of steepest descent. Now, an interesting question is, which is where we ended our last video, what will happen if you move in a direction which is orthogonal to the direction of the gradient vector? In order to make these ideas a little clearer, we have a small physical demonstration for you. So this is made using flour. You could use clay, or you could pick any sort of an object which looks like a hill. So the idea is that this is a representation of a hill. Okay, this is the base of the hill. This is flat. So we can perhaps use the XY coordinates to label points along this base, whereas the height, which moves upwards from the base, is our scalar field of interest. So for instance, at any given point XY, I can measure the height of the hill and label that as h x comma y, and that will constitute a scalar field. Now, at different points as we move along the hill, right, the height changes. And at each of these points, I can calculate what is called the gradient vector. So what does the gradient vector mean for this particular case? So let's say I were to pinch a hole somewhere here. Okay, I'm going to just show it to you. So let's say I'm going to pinch a hole somewhere here, which means this is our current location. Let's say at this location, I were to calculate the gradient vector. What is your intuition on where would this gradient vector point? You may pause the video for a moment and reflect upon what you think the answer would be. Well, in this particular case, the answer would be surprisingly simple. As you can see, the way the hill is made, it's pretty symmetric in shape, which means there is one direction, which is where you step. If you step in that direction, the height of the hill would change by the highest amount. And that direction is right up like this, right? And this direction is exactly what would be given to us if we were to calculate the gradient vector at this particular location. Now, let's say you were to move in a direction which is orthogonal to this direction. Moving in a direction which is orthogonal to this direction would actually lead us to move in a direction which is pretty much a flat direction, right? These directions are called contour lines or level curves on the surface of the hill. So if I were to move upwards, I'll move in a direction which will be given to me by the gradient vector. If I were to move 90 degrees to this direction, we move in a direction of what are called level curves or contour lines. So just to summarize, given a gradient vector, there are two very important directions associated with it. One is the direction of the gradient vector itself. This direction points the direction of highest ascent, highest change in the value of the scalar field. The other direction is orthogonal to the gradient vector, and this leads to what are called level curves or contour lines, along which the value of the scalar field does not change at all. Or in other words, the change in the height, dh, would be zero. The reason the change in the height is zero is because the direction which is orthogonal to the gradient vector will have theta 90 degrees, right? Because theta equal to zero is the direction. If you go back to the previous video, dr, if we keep our step size fixed and we move in a direction along the gradient vector, theta is zero, right? And that leads to the highest ascent. If you move in a direction, if you take a step in a direction which is orthogonal to the gradient vector, then theta is 90 degrees. Cosine of 90 degrees is zero. Therefore, the change in the value of the height along that direction will be zero. And these are called level curves or contour lines. So I hope this model helps you build a little bit more intuition about the gradient vector itself. And we'll continue this discussion in our future modules as well. Thanks for watching.